When a UPS, or uninterruptible power supply, rejects generator power, there are several potential causes and solutions to consider. It is not uncommon to experience this issue when integrating a UPS with a generator system. Firstly, phase synchronization is a critical factor. As suspected, the power from the utility, often referred to as POCO power, and the generator power might not be synchronized. This lack of synchronization can prevent the UPS from accepting the generator power. One potential solution is to swap the leads at the 480 volts disconnect. This process aims to synchronize the phases between the utility power and the generator power. However, it is crucial to use a power analyzer or synchronoscope to verify that the POCO and generator power are synchronized before swapping any leads. This ensures that the changes are made correctly and effectively. Secondly, a transfer switch issue can be the culprit. The transfer switch is responsible for seamlessly transitioning between the utility power and the generator power. If the transfer switch does not transition smoothly, it can lead to a momentary loss of power, which can cause the UPS to reject the generator power. Inspecting the transfer switch for any potential mechanical or electrical issues is essential to ensure it is functioning correctly. Thirdly, UPS configuration plays a significant role. Ensure that the UPS is correctly configured for the type of generator power available. Some UPS models may require specific settings or firmware updates to accept generator power. Consulting the UPS manufacturer's documentation and support resources can help determine the correct configuration settings for the specific generator being used. Fourthly, generator output should be verified. The generator needs to provide a clean and stable three-phase power output. Any fluctuations or inconsistencies in the generator's output can cause the UPS to reject the power. Inspect the generator and its voltage regulator to ensure proper operation and stable power delivery. Fifthly, wiring errors can cause the UPS to reject generator power. Double-check the wiring connections from the generator to the transfer switch and then to the UPS. Ensure that all connections are tight and secure. Any loose or incorrect wiring can disrupt the power flow and prevent the UPS from accepting the generator power. Sixthly, grounding issues can lead to problems. Inspect the grounding system to ensure that it is properly configured and that the generator is bonded to the same ground reference as the POCO power. A proper grounding system is essential for the safe and reliable operation of both the UPS and the generator. In addition to these potential causes and solutions, there are additional tips to consider. One tip is to gradually transition the UPS from utility power to generator power to minimize the risk of a disruption. Abruptly switching between power sources can sometimes cause issues, so a gradual transition is preferable. Another tip is to perform regular testing and maintenance on the UPS, generator, and transfer switch to ensure their proper functionality. Regular maintenance can help identify and address potential issues before they cause a problem during a power outage. If none of the above solutions resolve the issue, it is advisable to contact the manufacturer of the UPS and generator for technical support and troubleshooting assistance. They have specialized knowledge and resources that can help diagnose and resolve complex issues. The troubleshooting process may involve checking various parameters and settings in the UPS. This includes verifying the input voltage and frequency ranges, ensuring that they are compatible with the generator output. Most UPS systems have specific tolerances for input voltage and frequency, and if the generator output falls outside of these ranges, the UPS may reject the power. Another aspect to consider is the harmonic distortion in the generator output. Harmonic distortion refers to the presence of unwanted frequencies in the power signal, which can interfere with the operation of sensitive electronic equipment like UPS systems. If the generator output has high harmonic distortion, it may be necessary to install a harmonic filter to clean up the power signal. Furthermore, the impedance of the generator can also affect the UPS performance. Impedance is a measure of the opposition to the flow of alternating current, and a high impedance generator can cause voltage drops and instability in the power supply. Matching the impedance of the generator to the UPS requirements is essential for optimal performance. In some cases, the UPS may have specific requirements for the type of generator that can be used. For example, Some UPS systems are designed to work with specific types of generators, such as those with automatic voltage regulation or those with specific transient response characteristics. Consulting the UPS documentation, a manufacturer can provide information about the recommended generator types. The transfer switch plays a critical role in the seamless transition between utility power and generator power. There are two main types of transfer switches: automatic transfer switches and manual transfer switches. Automatic transfer switches automatically switch to the generator when utility power is lost, while manual transfer switches require manual intervention to switch between power sources. Automatic transfer switches are generally preferred for critical applications where a seamless transition is essential. The transfer switch should be inspected for any signs of wear and tear, corrosion, or loose connections. The contacts of the transfer switch should be clean and properly aligned to ensure a reliable connection. In addition, the transfer switch should be tested regularly to ensure that it operates correctly when utility power is lost. The UPS system itself should also be regularly tested and maintained. This includes checking the battery health, verifying the charging system, and inspecting the internal components for any signs of damage or wear. The UPS batteries are a critical component of the system, and they should be replaced periodically according to the manufacturer's recommendations. A weak or failing battery can significantly reduce the UPS runtime and reliability. The UPS charging system should also be checked to ensure that it is properly charging the batteries. Overcharging or undercharging the batteries can shorten their lifespan and reduce their performance. The internal components of the UPS, such as the capacitors, fans, and circuit boards, should be inspected for any signs of damage or wear. Dust and debris can accumulate inside the UPS, which can cause overheating and component failure. Regular cleaning and maintenance can help prevent these issues. Grounding is an essential aspect of any electrical system, including UPS and generator systems. A proper grounding system provides a safe path for fault currents to flow, which helps protect equipment and personnel from electrical shock. The grounding system should be inspected to ensure that all connections are tight and secure. The ground wires should be properly sized and connected to a common ground point. The resistance of the grounding system should be measured to ensure that it is within acceptable limits. In addition to the technical aspects of troubleshooting and resolving UPS and generator integration issues, it is also important to consider safety precautions. Working with electrical systems can be dangerous, and it is essential to follow all safety procedures and guidelines. Always disconnect power before working on any electrical equipment. Use appropriate personal protective equipment such as gloves, safety glasses, and insulated tools. Be aware of the potential hazards of working with electricity and take steps to minimize the risks. If you are not comfortable working with electrical systems, it is best to consult a qualified electrician. The integration of UPS and generator systems requires careful planning, installation, and maintenance. By understanding the potential causes of issues and following the recommended solutions, you can ensure that your UPS system will seamlessly switch to generator power during a power outage, providing reliable backup power for your critical equipment. Regular testing and maintenance are essential to ensure that the UPS, generator, and transfer switch are functioning correctly. These proactive measures can help prevent unexpected downtime and ensure the continued operation of your critical systems. Another consideration is the load that the UPS is supporting. Overloading the UPS can cause it to malfunction or shut down. It is important to ensure that the total load connected to the UPS does not exceed its rated capacity. The load should be calculated based on the actual power consumption of the connected equipment, not just the nameplate ratings. In addition, it is important to consider the inrush current of certain equipment. Inrush current is the surge of current that occurs when equipment is first turned on. Some equipment, such as motors and transformers, can have high inrush currents that can overload the UPS. If the UPS is supporting equipment with high inrush currents, it may be necessary to use a soft start device or a larger UPS. The environmental conditions in which the UPS is operating can also affect its performance. High temperatures, humidity, and dust can all shorten the lifespan of the UPS components. The UPS should be installed in a clean, well-ventilated area with a stable temperature. If the UPS is installed in a harsh environment, it may be necessary to use a ruggedized UPS that is designed to withstand extreme conditions. The UPS system should be properly sized to meet the needs of the application. A UPS that is too small will not be able to support the load, while a UPS that is too large will be inefficient and costly. The UPS size should be determined based on the total load, the desired runtime, and the environmental conditions. It is also important to consider future growth when sizing the UPS. The UPS should have enough capacity to support any additional equipment that may be added in the future. The type of UPS technology used can also affect its performance. There are three main types of UPS technologies: offline, line interactive, and online. Offline UPS systems are the simplest and least expensive type of UPS. They provide basic power protection by switching to battery power when utility power is lost. Line interactive UPS systems provide more advanced power protection by regulating the voltage and frequency of the utility power. Online UPS systems provide the highest level of power protection by constantly providing power from the battery. Online UPS systems are the most expensive type of UPS, but they provide the best protection for critical equipment. The UPS should be properly configured to meet the needs of the application. The UPS settings such as the voltage and frequency ranges, the battery charging parameters, and the alarm thresholds should be configured according to the manufacturer's recommendations. It is also important to enable the UPS monitoring and notification features so that you can be alerted to any problems. The UPS system should be integrated with a power management system. A power management system can provide centralized monitoring and control of the UPS, generator, and other power equipment. This can help improve the reliability and efficiency of the power system. The power management system can also provide reports on the power consumption, battery health, and other key parameters. The UPS system should be protected from surges and lightning strikes. Surges and lightning strikes can damage the UPS components and cause it to fail. A surge suppressor should be installed on the input and output of the UPS. A lightning arrestor should be installed on the utility power feed to the building. The UPS system should be inspected regularly for any signs of damage or wear. The cables, connectors, and other components should be checked for corrosion, loose connections, and other problems. The UPS batteries should be inspected for leaks, cracks, and other damage. The UPS fan should be checked for proper operation. The UPS system should be cleaned regularly to remove dust and debris. The UPS system should be tested regularly to ensure that it is functioning properly. The UPS should be tested under load to verify that it can support the connected equipment. The UPS battery should be tested to verify that it can provide the required runtime. The UPS alarm system should be tested to verify that it is working properly. The UPS system should be maintained according to the manufacturer's recommendations. The UPS battery should be replaced according to the manufacturer's schedule. The UPS fan should be lubricated or replaced as needed. The UPS components should be cleaned and inspected regularly. The UPS system should be upgraded as needed to meet the changing needs of the application. The UPS capacity may need to be increased to support additional equipment. The UPS technology may need to be upgraded to provide better power protection. The UPS monitoring and control features may need to be enhanced to improve the reliability and efficiency of the power system. By following these recommendations, you can ensure that your UPS system will provide reliable backup power for your critical equipment. Regular maintenance, proper sizing, and appropriate configuration are essential for optimal UPS performance.